Alright, so today we talk about metabolism of amino acid. Metabolism of amino acid. Now, when we talk about metabolism of amino acid, there are two things involved. Either you want to do the synthesis of amino acid, or you want to do the breakdown. Right? So when we talk about synthesis, it means you want to produce amino acid, you want to synthesize amino acid. When we talk about breakdown, we're talking about catabolism, you want to break them down. Now, for the synthesis of amino acid, we've already understand that the only amino acid that can be synthesized in the human body are the what? The non-essential amino acid. Non-essential amino acid. Meaning there's no way you can see something like biosynthesis of methionine in the human body. It's not possible. Why? Because methionine is a what? Is a essential amino acid. So you cannot synthesize it. You understand? Alright, so for this non-essential amino acid, only the non-essential amino acid can be synthesized, meaning as time passes by, we will talk about synthesis of glycine, synthesis of alanine, synthesis of each of the amino acid that can be synthesized. I get my point. But for the breakdown part, all amino acid can be broken down. Do you understand? All amino acid can be what? Can be broken down. So our main focus today will be on this breakdown. Let's say if we want to break down an amino acid, what is the first thing to do? I get my point. If we want to catabolize an amino acid down, what is the first thing to do? So I'll just put down the general structure of an amino acid. Here we have C, here we have COOH, here we have ammonia or amine group, then here we have H, then here we have side chain arrow. So the idea is this: if you want to break down an amino acid, the first thing to do is to remove the ammonium or this amine part, this amine part. You need to remove this part from this amino acid. That's the first thing to do. Now when you remove this amine part from there, what you are left with is what we call the what? The carbon skeleton. So what do I say is the first thing to do? The first thing to do for you to break down any amino acid is what? You need to remove the amino part, that amino group. Then what you are left with, so remove out the what? Or the amino part. Then what you are left with is what? The carbon skeleton. This carbon skeleton has 2 feet. It has 2 feet. One, it can either form glucose for you, or it can form ketone for you in terms of energy production. So those amino acids that after you remove the amino part, the amino acid now give rise to glucose. We call them what? Glucogenic amino acid. Glucogenic amino acid. While the ones that will give rise to ketone, we call them what? Ketogenic amino acid. I've already discussed this one for you before. Okay, so we said today we're looking at metabolism of amino acid, particularly the breakdown part. And I just told you now that if you want to break down any amino acid, the first thing to do is to remove the amino group. Is that not so? Now, in this removal of the amino group, it is usually done in 2 ways, basically. Because when you remove the amino group, that amino group now will then form ammonia. Then ammonia will now undergo the what? The urea cycle to form urea. That's what will happen. I get my point. So let me just summarize it for you again so that you get the main gist. Imagine here is an amino acid. I will just take a good example of one amino acid. Let's say aspartate, for example. Aspartate is a 4-carbon amino acid. So imagine here is the ammonia, here is your H, here is H2, here is COOH. This amino acid I just drew now is aspartate. Now if I want to metabolize aspartate, the first thing I will do is to remove this ammonia. I get my point. Now when I remove the ammonia, what I'm left with is now called the what? It's called what? The carbon what? Skeleton. This remaining part is called carbon skeleton. So we call it what? Carbon skeleton. Carbon skeleton. Meaning it just contains carbon. You've removed the ammonia part or the amine part. This amine part, when you remove it, it will form ammonia. Then ammonia will undergo what? Urea cycle and give rise to what? To urea, which will now be excreted. However, your carbon skeleton part has 2 feet. Are you there with me? It can either form glucose or ketone. So any amino acid which upon removal of the ammonia or the amine part, the carbon skeleton now give rise to glucose, we call it what? Glucogenic. Any amino acid after removal of the amine part, the carbon skeleton now give rise to ketone, we call it what? Ketogenic. Okay. Now let's now focus on that removal of the amino group. How do you remove the amino group? Now, usually for most of the amino acid, if you want to remove the amino group, you will first do what we call transamination. You will first do what we call what? Transamination before you will now actually do the removal, which is deamination. So there are usually 2 steps to it in order to get rid of the amine group. So in getting rid of the amino of the, let me just put it here, getting rid of the, or how do we do away with the amine group? I don't know the title to give it now, but it's more like what is the fate of the amine group, or how do we, or let me just say remover of the amine group. Now in removing the amine group, what we usually do first is what? Is transamination reaction, which is now followed by deamination reaction. So the first thing to do is what? Transamination reaction. Transamination reaction. Then you do what? Deamination reaction. In transamination reaction, what is just happening there is that we first transfer the amine group from one amino acid to another. Are you getting my point? Then subsequently, we are going to do deamination, which is the actual removal. So in transamination, it just means you transfer the amine group. Transfer the what? The amine group. Then in deamination, it means what? You actually remove the amine group. Do you understand what I'm trying to tell you? Alright, so let me give you a practical example. Again, let me pick the aspartate. If I pick aspartate now, we just draw the structure here. Let's say aspartate. I just write aspartate here. If aspartate want to undergo transamination reaction, once it removes the amino group, what will be left in aspartate is what we call oxaloacetate. Oxaloacetate. Are you there with me? It means that we've removed the amino group from what? From aspartate. What we are left with is a what? Is a keto acid called oxaloacetate. Now, the question now is, who received that amino group that we just removed from aspartate? Who is the receiver of the amino group? Usually, the receiver of the amino group is what we call alpha ketoglutarate. So alpha ketoglutarate we receive the amino group from aspartate and give rise to what we call glutamate. Do you understand? So it means that that amino group that was previously in aspartate, let me just use this star to represent it, is now in what? In glutamate. Do you understand? So transamination reaction, it just simply means you are transferring the amino group from one amino acid to form another amino acid. So previously, okay, let me show you in structure. This is aspartate here. It contains 4 carbon basically. Here is the amine group. Here is your H. Here is H2, and here is COH. If aspartate now want to undergo transamination, once we remove the amine group, which is this one, once I remove this group here, What is left inside? What is left there is what? It's just the carbon skeleton, right? So we have COOH, we have C, we have C, and we have on that COOH. Is that not so? And here is H2. Here now will also be H2. This structure I just drew now is what we call oxaloacetate. Oxaloacetate. So oxaloacetate is same thing as aspartate, but now it does not have the amine group. Now the question is, who received this amine group? The receiver of the amine group is usually what? Alpha ketoglutarate, which will now give rise to what? So glutamate. Meaning it is when alpha ketoglutarate receives the amine group from aspartate that it now changed to what? To glutamate. So glutamate is the new amino acid that we form. Do you understand? Okay. Meaning this amine group that was in aspartate is now in what? In glutamate. Do you understand? All right. So let me give you another example of transamination reaction. But before I give you that example, the name of the enzyme that does transamination reaction is called transaminase. Transaminase, or you call them aminotransferase. Transaminase or aminotransferase. So the name of this particular one now, since it is involving aspartate, we call it aspartate transaminase. The short form for it is called AST. I believe you've heard of AST before. Okay, so let's proceed. I'll give you another example now. Let's say, for example, I want to take alanine. Alanine is also another amino acid. If I want to remove the amino group from alanine, once I'm done removing the amino group from alanine, what will be left will be pyruvate. So after removal of the amino group from alanine, what I got was what? Pyruvate. The question is, what receive, or which group received the amino group? And I will answer you by saying what? Alpha ketoglutarate to form what? Glutamate. So that is the idea behind transamination reaction. It's just that an amino acid, alanine, decides to undergo transamination reaction and transfer its amine group to what? To glutamine. To glutamate rather. Do you understand? Okay. So alanine, after undergoing transamination reaction, forms pyruvate. Then who received the amino group? Alpha ketoglutarate. What did it form? Glutamate. Do you understand? Okay. Now, if you understand up to this point, again, what is the name of the enzyme involved? The enzyme is called what? A transaminase enzyme. Transaminase enzyme. Now, which particular transaminase enzyme is this? It's called what? Alanine transaminase. Meaning, short form is what? ALT. Now, these two examples I give you concerning AST and ALT are the most common example you see in your textbook. Okay, they are the most common ones in relation to transamination reaction. They best explain transamination reaction. So in simple word, how will you define transamination reaction? You will say transamination reaction, transamine, meaning we are transferring the amine group from one amino acid called the donor to a keto acid called the acceptor in order to form a new amino acid. You understand? So transamination, you transfer from one amino acid called the donor. So who is receiving it? A keto acid to form what? A new amino acid. Okay? So that is the idea behind transamination reaction. That is the idea. So the two examples I want you to know for transamination reaction is, if for example, if I pick alanine will give rise to what? We form pyruvate, right? Then who receive the amino group from alanine? Alpha Kg, giving rise to what? To glutamate. Meaning the amino group that was previously in alanine is now in glutamate. Now, the question you will ask me now is that what is the fun in doing this? Why does alanine add to do transamination reaction and form glutamate? Why did alanine not just go to deamination straight? Because the thing is that the enzyme that does deamination reaction only recognizes glutamate. So all amino acid, in essence, we need to form glutamate before they can remove the amino group. So what they do is that all amino acids will be like, oh, let me transfer my amino group to glutamate. Let me transfer my amino group to what? To glutamate. They themselves cannot undergo deamination reaction. The reason is because the enzyme that does deamination reaction only recognizes glutamate. The name of the enzyme is called glutamate dehydrogenase. Are you there with me? Glutamate or dehydrogenase. So that's why all amino acid which choose to undergo metabolism or breakdown must first transfer, the word is transfer, they must first transfer their amino group to what? To glutamate. Glutamate now will now undergo what? Deamination and remove the amino group. So the key point about transamination reaction, or we will now write now, silent features of transamination reaction. Silent features. What are those silent features? Number one, in transamination reaction, there is no removal of the amine group. No removal. Only what? Only transfer. Only transfer. The only reaction that will remove the amino group is deamination reaction. So in transamination reaction, no removal of the amino group, only what? Transfer. So number two silent feature is that all transamination reactions are reversible. All transamination reactions are what? All transamination reactions are reversible. Very, very important though. All transamination reactions are reversible. Meaning, if I want to write this reaction, if I want to put it proper, this can reverse back. Sorry. So that is it. So the third point again about transamination reaction you must know is that transamination reaction can be used to synthesize. Transamination reaction is used to synthesize non-essential amino acid. Non-essential amino acid. That's why I teach you non-essential amino those classification first, so that you get an idea. Remember, the non-essential amino acid are those amino acid that cannot be synthesized in the body. Sorry, they can be synthesized in the body. Sorry. So the non-essential amino acid are the ones that can be what? They can be synthesized in the body. So for example, now we just discovered that we were able to synthesize what? Glutamate, right? And if this reaction is reversible, it means we also synthesize what? Alanine. Now if you go and check that video I taught you on classification of amino acid, you will see where alanine and glutamate are examples of non-essential amino acid, because they can easily be what? Synthesized in the human what? Body. So that is it. So number one, there is no removal, only transfer. Number two, all transamination reactions are reversible. Number three, transamination reaction is used to synthesize non-essential amino acid. While number four, all transamination reaction all require what? Require vitamin B6. Vitamin B6 called what? Pyridoxal phosphate. Pyridoxal phosphate. Okay? All require vitamin B6. Very, very important. Very, very important. Then number five is that number five on transamination reaction is that, okay, I've given you that all are reversible. There's no transfer. Can be used to synthesize non-essential amino acid. Then there are certain amino acid that does not undergo transamination reaction. A good example is what? Threonine, lysine, then proline, and hydroxyproline. These amino acids, they don't undergo transamination reaction. So these are the few silent features of transamination. Okay, there's one. Hey, I know I'm missing some. Alpha ketoglutarate. Alpha ketoglutarate acts as the general acceptor or universal acceptor of the amine group. Acceptor of the amine group. Okay, you saw it now. For the one I talk about aspartate, it was alpha ketoglutarate that received the amine group. For the one I talk about alanine, it was the same alpha ketoglutarate that also received the what? The amine group. Okay, so that one is very, very, very important. Very, very important. Example of amino acid that does not undergo transamination again is what? Threonine, lysine, proline, and hydroxyproline. So that is the cache behind transamination reaction. So in summary, transamination reaction is just a reaction in which the transfer of the amino group from one amino acid to another, majorly so that at the end of the day, all amino acid will transfer the amine group to form glutamate. Glutamate now will now go to the liver to undergo deamination. Are you getting my point? So they ask you what is the reason for transamination reaction is so that the amino acid can first form glutamate before they will now undergo deamination reaction. You understand? All right, so I hope you understand. Thank you very much.